Well, all right, here we are. Well, here I am. Anyway, you remember what the beginning of this whole start of this series that I told you this thing got some strange problems, and you know, it's locking really good. I think I fixed the lock problem. I think it was just some of the adjustments were just on the edge. However, during the one of the last alignments, I noticed that the frequency was wrong on 1 megahertz and below. That's not right. So the other thing that I did is I went through the front panel meter calibrations, and I didn't record all that because I had to go through multiple sections to find the right damn reference material for it. But that time I didn't feel like recording it. I just went on. But anyway, I moved on. And one of the last things that I had to do is go do doing the AM alignment on it. That went fine. But the next thing that I did was let me see if I can find it. What is this called? Don't remember. Down conversion adjustment. Supposed to set it says model 3002, but one okay, it doesn't matter, it's on there. I have a M115, but basically you set your output frequency levers to 1 megahertz. Look at your spectrum analyzer or power meter, whatever, and get a reference. In this case, at 1 megahertz, it was 3.2 dBm, I believe. Then you're supposed to change it to 999 kilohertz or 0.999 megahertz. You're supposed to see if they match, and they did not. I went from plus 3 to minus 23 dBm. Yep, I did. That's pretty significant. Shouldn't have done that. So there is a problem somewhere. Everything goes through the M115 board. And I opened up this board. Kind of wish I hadn't have. Now I put my hand on this board while it's still operating. It's super hot. Remember that. Super hot. Really hot. I'll show you why. Wonderful cinematography, right? This is the M115 board. Look how dark that circuit board is. We've got 1, 2, 3, 4 capacitors. I don't remember if I did that. I think I did 15 years ago. But you got 2 big old 1 watt resistors there. 1, 2, 3, 4, 5. 5 of these caps here. Then you got these 4 electrolytics here. You got a NE5534 right here. You got a little like a little power transistor there. Bunch of resistors. 2 big old output transistors right here. On the other side, you got a couple of ICs here. This right here is supposed to be, I think, the level meter. I mean the level adjust, which did nothing. And here's another chip right here. So this is a little amplifier. This thing has got a bunch of amplifiers to it. So we're finding problems left and right. I'm having to deal with them. It may seem like I'm just bouncing around, and yeah, I probably am, but one thing that you have got to do when you're doing this stuff is pay attention to what it's telling you. I've already had to backtrack a couple of times because I didn't read everything. It's like when we were adjusting this M172, I did not read it thoroughly. I just barreled through there like some, like kind of like jumping off the Niagara Falls and not realizing that you really don't need to do that. Anyway, so this is kind of where we're at, finding out what is changing. So this really means that I'm just going to do some static tests of resistors and capacitors and all this kind of stuff. I'm sure as hot as this thing's getting, don't really disturb this because this is RF. But basically what happens is with this module, when you get down to 1 megahertz and below, what happens is there's a switch, and that could be part of the problem. Think about that. The switch here, I believe, tells this thing when, I may have to check that, that might not be right, when you change, I'm sorry, it's not the switch, I'm sorry, I don't know what the hell I'm thinking about. It's got, if I can remember the theory, hang on, where is my paper, let me find my paperwork. There is a 13 input, oh, what is that thing called? About time to call it a day, honestly. Give me just a minute to find it. Well, shit, where is it? Find my ass a hole in the ground sometimes. Well, guess I ate it. This is so special. This is just so special. Here it is. Good Lord have mercy. God. Oh my God. Anyway, right here, 74S133. When you turn your binary switches here, when it senses, when you get to about 1 megahertz, it decodes this right here, and when it sees that, it activates a coax switch on the output section, which I think is this board here, the M10W. It activates, the RF comes out of this, goes into this guy, gets down converted from 10 megahertz to 1 megahertz. So if that relay wasn't on, this thing is putting out 10 megahertz, and if you go to say like 9.95 megahertz, this thing would down convert it to 995 kilohertz, and then it takes that. Basically, this thing is, now that your output is switched to this has to attenuate it, it has to down convert it, it's got to re-amplify it and spit it right back out. Basically what it does. So the output level is way down, which tells me I probably got transistor issues. So from now, I'm just gonna look, it ain't no point in y'all watching me do this. I'm just going to sit down and I'm going to check transistors, resistors, capacitors, the usual thing. So I may not get back today. So I may call this, it's been probably an hour and a half video. I may have to cut that in half too if I decide not to, if I don't decide to just cut it all off and throw it in the garbage as far as the videos. Anyway, thanks for riding along. I know it's helter-skelter, but it's just the fun part of doing these things. So, talk to you later. Okay, guys. This is getting interesting. I'm hoping I ain't barking up the wrong tree. Here's the module. Got it laid out here, and I have my dual power supply connected to it. Hopefully I got it right. Pin 3 here is plus 18, pin 4 is minus 18. I have my signal generator putting out 800 millivolts signal. I don't know if that's enough to drive it or not, but at least I can see something. And I have my jet engine here. I've got my spectrum analyzer connected to my active probe. I'm going to measure the throughput of this and see what exactly is happening. So I think I'm just going to put y'all on wideband. Put y'all back here on this, so y'all can watch me blow up a perfectly good board probably. Go back here. Not sure where to put you guys. Upside down, dude. That ain't gonna work. Oh, this wonderful cinematography. Just get me out of the picture. Still can't see the spectrum analyzer. I'll just move back. Alright, well, hope I got this right. Fire in a hole. Drawing about an amp. Check it with my DC voltmeter. Let's make sure that power is what's supposed to be going to. So Q101. Q101 is on this board here. It's this transistor here. I know you probably cannot see it. That's alright. I want to check the collector, which is connected to L108. So you just got to find L108. Nothing simple on this. I just measure. Yeah, I got -16 there. I got +9 there. Okay, let's see what we got signal wise. You're gonna have nothing signal wise because some dumbass didn't hook it up properly. Genius. My gosh, I make some dumb boneheads. Okay, about to check the input. It comes right here straight to there, so let's see what I got. The active probe, you can see the spectrum analyzer. The active probe pretty much is a high impedance source to whatever you're measuring, and the probe actually, the active part of it, the amplifier right here, it actually takes it amplifies it. It makes up for the difference in the loss of the cable and the isolation, and it's very handy for troubleshooting RF circuits like it. So we got about a -6.7 dBm coming in. So we can make a reference line on that. Look, wrong button. Where is my reference? Reference level. Not my reference level. What the hell am I looking for? Reference line. Okay, anyway, I can't find it. We got about a -6.4 coming in, so we'll go into this ring mixer right here, or balance mixer. So we're basically looking for something coming out of, I need to find Q201. Okay, so somehow or another it comes from the mixer here. Here's the 4 diodes. See if we got any action on Q101. Turn the generator off a second. This should be a reference oscillator. I'm going to change my frequency span. Not sure about that. I thought I would be seeing some kind of a signal right there. Base Q. Not seeing anything. Well, that would probably kill it. Not seeing no activity on this. Let's find L105. I'm not seeing nothing on that transistor at all. L105. Okay, so where in the devil is that? L111. Not sure what that is. Sure what I'm looking for here. I forgot what my oh, that's supposed to be 10 megahertz. That's why I'm not getting nothing. That's supposed to be 10 megahertz input. So tell you what, I want to back that out and I want to put that 10 megahertz in here. Let's see what I got now. I do have an output on the collector. Such as it is. Yeah, I'm going to have that. About a minus 45 dBm right there. Yeah, my lordy, let's see. R105. Hardest part about this is just figuring out where everything is. Can't hardly read the writing on this thing. There's R105, big old dude right there. That's in there. Minus 44. Should have plus voltage on it. It does. So this is the collector. I got 9.29 volts there. 9.29, 9.3 there. 15.75 there. So I'm definitely on the collector and have a signal. Just barely there. Down in the dirt. I definitely have a signal coming out of this thing. It's very, very small. Out of one of these. I'm trying to learn this thing. L110. See what makes it tick. R105, L107 and 106. It's closer to L110. So C112, probably that one right there. So let's see. There. A little bit of signal there. Have a lot more signal coming into it than actually making it to it. 9 and 8 and 9 of 102. So 1, 2, 4, 5, 6, 7, 8, 9, 57, 9, 32. Actually pretty good considering. I need to get some 5 volts on this. Alright, I didn't have any I didn't have one of my voltage inputs on the board, so let's try this again. Yeah, now I magically don't have crap. Yeah, me. All I did was fix it. There it is. I don't know why it wasn't working. Okay, well I do have a signal. I do have the signal. It's at minus 40 dBm, so this thing was apparently amplified. So it's going to CR 101 and 103. That is going to be these guys here, so 101 and 103. They're here. I need to go to the actually 102 and 103. Where in the shit? I need to go to the cathode of these two diodes here, here. So that cathode there, I have a signal. That cathode I don't. Push-pull CR104. This is the same problem, looks to me like, that I had with my mod meter. I had that open transfer, that mixing coil, that ring coil in it. Oh my gosh, T101. T102, T101, T102, just here. Nothing there. Nothing there. There. Just quit working again. Don't have a good connection on something. Again, I want to look on the output of this transformer. So it is balanced. I do have a signal going through the transformer, you can see. It's a center tap little transformer. So need to find L103 now. L103 right over here. So I should have some kind of a signal at the output. Can't get it good. Don't know. Something's just coming and going on this thing. I really don't know what. Connector here. You're only as good as what you got, you know. Well, as warm as it's getting, it's doing something. Not getting any bleed through out of that. I would have thought I would have got something, but no, I don't get anything because it suppresses the input signal. So I got to have signal coming into this thing. So I'm going to bring out the big guns. I'll set up for 10, so I'm going to set up for about 10.5. Finally get to use my signal generator for something decent. Can't never have enough cables, can you? So I'm running at about -10. You gotta do what you gotta do, boys and girls. It's only 10 megahertz, so I'm not really worried about stray RF. I'll show you what I'm doing here in just a second. I know, this is confusing as shit. Y'all pissing y'all off, I know. Anyway, basically, look, here's 10 megahertz right here. This is your reference. Comes in through this little gate right here. Comes back around, comes through this amplifier. It's amplified, applied through this little transformer right here into this mixer, little diode mixer. Then your signal from the output of your that's coming out of your amplifier module, comes through here, goes through this transformer, is balance mixed. This is the product right here. So now that I've got a signal coming in here, I have a signal coming in here. Let's see if I got a signal coming out. All this mess works. Don't blow it up. So, what am I looking for? I'm looking for L103. It's right over there. It is amplifying, but I'm not seeing the product come out of this. So if I have 10.5 megahertz coming in, and I'm referencing it, I should get 500 or 1500 out, or 10.5 out. I'm sorry. Golly. I should get a product of 10.5. I think 500 kilohertz. So I think I am. Changed it. Sorry. I'm getting something. Don't think I have enough drive. I'm just not getting enough drive. I don't think this chip is passing that signal. I'm going to bypass the chip. So, turning everything off for a minute. I'm going to pull that chip just so I can bypass it. IC102, which is this one. Don't believe the chip is bad. Hands are a little dirty on it. Now I got to find, I'm just bypassing in 8 to 9. It's right there, so I'm just going to find me something to shove in there. I can think of what the hell I got. Sacrifice a resistor or something to cut the leg off of. Get a 10 ohm resistor and I'm going to attempt to push it in there into that socket. I don't want to solder anything. I thought this was going to be easy. Famous last words. Thought it was going to be easy. And I'm going to reduce the signal level to 0.8 volts. Now, power up everything. Let's see if we got something different now. There we go. Back to center frequency of 10 megahertz. See what I got now. There we go. That's a little better. Minus 20. Yes, we definitely got some amplification going on now. So now I'm going to set it up for 1 volt input. Oh yeah. So now, if I get everything right. Yes. We do have a signal. Minus 61. It may just not have enough drive. about minus 38 at 500 kilohertz. If I vary the frequency varies. So if I take 10 megahertz away, okay, I think that section is working. Now I need to check the other side, so I got to turn all this crap off and flip this. Figure out how I can do this. Shorten out something. See, everything is popping loose. Pause you. Well, let me recap what I'm doing, okay? This M115 board here, basically it's a down converter. It takes the 10 megahertz reference and mixes it with a 10 megahertz signal coming out of the VCO, the main VCO, actually it's actually 10 megahertz signal coming from the output, which normally goes to the output module and then out the unit, out the signal rate, out the port. God Almighty, I can't talk. But what this does is there's a relay inside the output module that when it says, okay, you want to do 1 megahertz or below, that's fine. So what it does is that relay switches in, it cuts in this circuit, it actually reroutes it to this. So the routes the 10 to 11 megahertz in from the coax switch, mixes it with 10 megahertz from the crystal reference oscillator, and creates some output. So I had 10.5 coming in, and I had 10 megahertz reference coming in. And I saw 500 kilohertz come out. So if I don't know. Am I thinking that right? Oh well. Let's power it back up, see if I can get a signal through here. Here we go. It blows up, it blows up. It'll be the first time. So what I basically want to do is I just want to look at the gains through all these stages. So Q201 is on the other side. Q201 is over here. Take my little signal generator. I must be tired. It's stupid. This is really getting on my nerves. Output's not turned on, is it? Who did that? Okay, there's the signal. Signal there. So I do have some gain. I got about minus 42. About minus 39 right there. There's gain compared to what I think's the base. Quite know how it gets through there, but who cares, right? So let me get that gain figure in. Alright, minus 39, okay? So Coming over to pin 3 of IC 201, so little IC right there. Hang on a second. This is the input from the output module. Comes in through here, goes through this mixer. This mixer gets its local oscillator signal basically from the 10 megahertz reference oscillator. Anyway, it mixes, creates you a sum frequency of, in this case, be 500 kilohertz. This is the transistor I'm looking at right now. I got about a minus 39 coming out right there. Considering the way this is hooked up, that's fine. Now I'm coming over to this IC right here to pin 3, which is the input. So, if I can do this without exploding. I got minus 39 there. Nothing there. Okay. Oh, bring it back. Okay. Don't have a clue what part this is. Just continuing on with this M115 down converter in this Wavetek 3001/UG1156 RF signal generator. And the last segment or two, whatever it was dealing with low throughput through this device, or it appeared to me like it was. So I probably hastily went through this thing. It's just, I always forget I'm being recorded and I don't quite think linearly about this stuff. But the input right here comes from the coax switch. This comes from the output module. I think it's the M10 module. Anyway, the output is routed through here when you go below 1 megahertz. So it's routed through here, comes through this mixer, has a there's 10 megahertz right here. It's routed through here, comes through this tuned circuit. Don't quite know what that's for. But anyway, it goes into this amplifier and is supplied to part of this diode mixer. A balanced diode mixer, I think this is what this is called. But anyway, your input comes in here. Your local oscillator, I'm calling it, comes in here. It gets mixed, gives you a sum and difference output. In this case, I think it was I had, what was it, 10.5 meg coming in here with a signal generator, 10 megahertz from another signal generator. I was given 500 kilohertz out here. Okay, so I did have gain through here. I did have hardly couldn't measurable signal here, but I had plenty of output here. But I lost signal here. The only thing in between that is this 100 microfarad capacitor and this resistor. So at 500 kilohertz, I believe this thing should have passed more than it was passing. So I just clipped it out last night, left it there. Today I got back from work and done everything. I went ahead and put it on my capacitor analyzer on this my resolver. So I have it set up as aluminum electrolytic. I got the values plugged in, 100 microfarad at 25 volts. Watch the capacitor value. 535 picofarad. Capacitor ESR, 100 at 25 is out of range. Ladies and gentlemen, that capacitor is open. However, it had no leakage, but it was open. So I think that might be part of the problem. It's sure a problem. Well, that'd be part of the problem, but it's a problem. So I got to see if I've got anything like that and replace all those caps in there like that. So I will do that and bring you back, and we'll put this thing back together and see if it made any difference. Hopefully so. We can move on. All right, I'll bring you back. Okay. Back on the M115 down converter module, which is this guy. This blue capacitor right here was open, and that's where I had a lot of loss through it. Yesterday when I was measuring signal throughput, through the stages using my spectrum analyzer's active probe. So what I'm going to do is I'm going to change all 4 of these caps, and I had to dig around. I've got kind of a mismatch of parts, but they ought to work. For what I'm doing with it, it'll work. So I got to take some of this stuff apart. You can see it here. There's 2 screws right here, if you can see. One here and one here. And also a connection here, which is the output from the board, from the module. These 2 output transistors here, I got 2 screws that I got to take loose, get them out. So the whole board should come out this way. I'm going to remove these caps, replace them, and put them back in, clean the board up. I'm going to check some other components while I'm at it, and put the board back in and recheck everything. So I could turn this on, turn this off, and do this, or what do you think? Already 14 hours long. What the heck? So I have my soldering iron warmed up. First thing I'm going to do is disconnect. I'll tell you what, let me get y'all closer. Now I know when you're in frame or not. Okay, here we go. I need my glasses. Yep, there they are. I gotta have my close range glasses. Alright. Start with the wiring that we gotta take off to move the board. Okay, got that done. I don't think there's nothing else that I got to be concerned about at this time. I need to take these two transistors loose. What's that look like? Here we go. I think it comes off this way. Little short 440 screws. A couple of them. Get them out of the way, so that's good. Put you back in frame. Turn on my desoldering machine. Before I get too carried away, I'm going to mark the positive side of these capacitors, which looks like I already have, but we'll mark them anyway. They seem to be all the same. See if this thing will lift out. Some of these components look quite baked. If I can get this done without breaking something. Alright, the desoldering machine should be warmed up. A little Heiko, what is that thing? Heiko FR301. Looks like a phaser. Seems like I changed these Probably about 15 years ago when I originally went through this thing. We'll check these things in a minute. So anyway, got that one out. It's 125. Yep, got the wrong one. This one's the one that's definitely bad. So, let's see. I think I sucked that lead up. I have to pull this thing apart to get that lead out of there. I didn't want that to happen. Yep. Yes, sir. I'm going to have to push that out. I'll push it in. I was afraid that was going to happen. Yeah, I had a lead that I cut off the capacitor, and it soldering device sucked it up in there. Okay, good. Now, this is a thin circuit board. I think they call this a FR4, but I'm not sure if that's what it is or not. Very thin. This G-coil's very delicate. One to go. I'm probably going to order some nice, good, high quality capacitors for this. Probably going to see if I can get something higher than 105 degree centigrade ratings. So all of these are 125. So let me get you set up to look at the capacitor tester. Turn that off. We'll check these things. Alright, turn that around here. Get you up there where I want you. Alright. Already got the values programmed in it. This is, I think, the first, no, this is the next capacitor right here. So what we do is value 449 picofarad, capacitor ESR, out of range, capacitor leakage, it's good, but the value appears to be open. These are Zycon capacitors. I think I ordered these cheap off of eBay or Mouser or somewhere. They didn't hold up, did they? Alright, here's the second capacitor, or the third capacitor. Here we go. Capacitor value 484 picofarad. There ain't no point checking the ESR. Another 100 microfarad. 463 picofarad. So far 3 out of 4. This is the first one we checked. It's going to measure about the same. The electrolyte in these things probably just evaporated out because this module gets extremely hot. 547 picofarad. All 4 of them bad boys are bad. Let's check this one here. It's on 100 at 35. So let's put in 35 volts. This capacitor I had in my junk box. Value 115.5 microfarad. Check the ESR on this dude. 1.41 ohms, good. Dielectric absorption. Good. And finally leakage. A little low. Yeah. So long as it sees a trend going upward, it'll be fine. Okay, that one's good. So now I just have one Mouser cap, 120 at 40. It's a really good looking cap, and 2 Radio Shack caps. So, alright, let's get you back over there on the other side. Let's get this module put back together after we change the caps, of course. There. So, here we go. I'm going to put this old ratty looking one over here. Don't know what circuit it's in. It's in A circuit. Pop up on. Get a little bit of solder. Check that. It says here there's a capacitor. One of these capacitors. Let me look at which one it is. It's got the plus in going to ground, which is probably good. But let's find out which one it is. It's C214. C214. Where's C214? There's 213, 208, 202, 201, 218. C214. There's 13. It's on this module somewhere. $16. No idea. There's 1,000 ohm connected to it. Where are you? Yeah, I would like to find it, make sure that it's actually in there right. Well, we didn't have a capacitor in there, and everything's been right about this schematic so far. I guess I'm freaking blind. Ain't far from the truth. On the schematic, I mean the pictorial here. 1000 microfarad. There's R214. It goes to R214. R214. Okay, R214. It also runs down to like a 27 ohm resistor. This is saying it's a 360. And it's also calling it R215. So I have 213, 206, 203. 206 and 203. There's 203. Boy, ain't nothing simple about this. There it is, 206. That's the one that we actually went into the first time. Okay, it's marked 215, it's marked 360, which doesn't match anything. I'm putting 100 in there. But it is in the right polarity. It was in there before and it seemed to work, so we're putting it in there again. I just wanted to make sure about the polarity on this one because it was backwards. It could have been backwards because alright, you're a little bit out of frame, by the way. There you are, we'll back you up a little bit. Widen down just a little bit, there we go. There's some more capacitors in here. I'm really thinking about checking them. Alright, let's take the good one here. Actually 120 microfarad, but you can always go up in value a little bit. Instead of never go low in value, but you can always go up in value a little bit. I don't see where it hurt a thing. Besides, values are just guidelines. Right, I'm about to replace the capacitor that I think was the root of the trouble. Old capacitors. Capacitors, I'm going to just rough guess out there, are probably 80% of most electronics is problem. Electronic devices is problem, however you want to pronounce it. I mean, you know, when you work on a piece of equipment, it's not working right, flaky, not coming on at all. X-Ray Tony B had a good saying, or has a good saying, that one of the 10 commandments of troubleshooting is thou must check thy voltages. So if you have an issue with something, always check your power supply voltages first. Even if you think it ain't related, unless you just know for sure it's not related, check your power supply voltages. That includes ripple. Use a DC meter and a scope. Look at the power supply. These are 85C capacitors. So if I'm definitely got to order some good capacitors for this. And I'll probably get some. Well, I've run my memory card full. That ought to be interesting. It'll be one hellacious video. I'm gonna have to split it up. Anyway, where the hell was I? I don't know what all I got all the 4 capacitors changed. I pulled out a little 10 at 25. I'm not sure what kind of capacitor that is. Could be 10 on them. I don't know. Never really looked it up. I'm about to. I'm just gonna come over here and check it real quick. So we'll do this all over the count. I'm gonna call it a tantalum. 10 microfarad, 25 volts. I think this is a tantalum cap. I'm not sure. I think it is. Check the value. 10.8 microfarad. Check for leakage. .52 microamp. That's good. What up doing that? 1.9 on the ESR. Okay, bot check completed. I'm confident the rest of the capacitors in here like this will be fine. So all I got to do is put it back in. You got to get it in there. Biggest problem is getting it in. The other problem is keeping it in. You know how it is. Alright. Everybody wants to get in the show. Prop it up so I can get solder on it properly. I hate soldering in a vertical position. Solder never pulls where you need it to. Okay. Oh, I got one more I got to solder. That one where I accidentally unsoldered the wrong component. All right. Gotta put it back together. I had said I'm going to spot check a bunch of these components, but I really ain't. There's no point in it. If it still don't work, then we'll redo it. I'm just ready to move on. Ready to move on. Yep. Can't believe I filled up a video card. And of course, it ain't wanting to go in. That ain't wanting to come out. There we go. Rule of thumb, never tighten everything down till you get all your screws in. Got to resolder that output lead. And you got to turn it over and remove that jumper that I put on this chip socket yesterday. A little mismatch of capacitors, but they're close enough to work for right now. There's my jumper, such as it is. Get the IC back in. Okay, put the cover back on it. So it came off, I don't know. Marked everything but that. Only goes one way. In, out, 10 megahertz. Alright. Trying to pick these stupid little star washers up. Hard to do. Okay, I'm going to shut this off for a minute and finish it up and get it in the case and get it all cranked up, and I'll bring you back. Okay, I have the signal generator put back together. I have it dialed up. It is locked. I have it dialed up on 1 megahertz. And the output is being fed to my spectrum analyzer. So, if I remember right, without looking back at the manual, what we're wanting to do is go from 1 meg to 999 and look, see, it's minus 20.6 dBm right now. And I'm on minus 20, and I'm at 0. That means that's minus 20 coming out here. This is minus 20. So now, according to the book, I changed this to 999 or 0.999 megahertz. So now I'm at 999 kilohertz. Look at there. Still the same. I'm about 18.9, but that's the level thing. So let me bring the level down. Yeah, remember how to do it. An adjustment inside the M115 module that affects the level. There you go. Now I'm at 20. If I go up to 1 meg, so that repair was a success. Awesome. That was a success. Now I'm going to, remember it was all frequency yesterday. I'm going to put this on the freak counter, so let me let's change that. Let's put that on the freak counter. And remember we had that frequency issue. So let's hook this back up and let's make sure. Remember it was at 1 meg, it was like 1.03 something. Look there. Right on the freaking button. Hey, that fixed that problem. So let's put this thing at 800 kilocycles. I like it. We fixed 2 problems with 1 stone. Awesome. Boy, I'm liking this. Let me shut it down for a second, the camera down for a second, and let me get my manual back out and take off where I left off. Be right back. Alright, I actually found out where I left off, which we have done that. Final frequency checked, M30-1. We're at 5.3.12. Connect frequency counter to the instrument RF output connector, which we are. Let's see, set the front panel controls as specified in 5.3.4. Let's go back to 5.3.4, 5.3.9. Let's see, must be this one. Frequency vernier and calibrate. Okay. Modulation mode, CW. Good. Modulation frequency, external. Modulation FM AM minimum. Output vernier, fully counterclockwise, which it is. And for plus 10 dB output, which is basically maximum. Alright, now let's go back. Yeah, ain't another frequency we're reading on the counter. I'm at 800. I agree with that. So I'm at 100.8. I agree with that. $500. 501. Buddy, I am good with that. I like it. So let's go back to FM times 1 kilohertz. Bring this up to 5. We'll zero this out. Look at there. I've got it set for 5 kilohertz deviation. Oh, let's look at the audio. Let me see. 1 kilohertz, FM time 1, set for 5 kilohertz deviation. 5 kilohertz deviation. See, I'm set up for FM. Buttons out. FM. 5 kilohertz times 1. 5. Look at that waveform. Beautiful sine wave. Good. Now, times 10. We're going to go to FM's time 10. So 10 times 10 is 100 kilohertz. I've got to set this. Look at there. 1 times 10, 100. Look at there. Man, that is cool. So let's go back now to AM. We're going to go back AM and we're going to set this for 50% modulation at 1 kilohertz. We'll set this for AM. Little off. Look at that 1 kilohertz. That's good enough for this thing. I'm satisfied. I believe this is done. Looks fantastic. So I'm going to set this back up on FM times 1. It's back in FM mode. What I want to do, don't need that noisy thing. It is calibrated as good as we're going to do it. Well, mere mortals. Oh my gosh, I got so much junk. I got this big ass analyzer right here in my path. I can't get to nothing. But what I want to do, I want to send a little analog digital signal through here. Analog. So we're going to send some through my Motorola code synthesizer. I'm just sending some digital private line that's used for two-way communications. Oh, I got to put the code in. Oh, two things. There, there's some tone. This is external. Thing doing its job. Perfect. It does everything I want it to do. The output's calibrated. It locks. It is done. And let's see, what did we take? 4 capacitors in the M115. 4 capacitors in the M115 module. I replaced was it the M172? Yeah, I replaced 3 3 op amps in there, and I replaced the op amp on the modulator board. So, and there you have it. It's now a working, clean machine. So, I'm happy. Play around a little more, but you see, it had these various problems. And you know, not locking properly and all this kind of stuff, and really didn't know which way to go because it's really complicated. So I just followed the alignment procedures, and the alignment procedures, all I did was looking for what worked and what didn't. And as you've seen, if you lasted this far, as you've seen, that when I found something wrong, I repaired it. And figured out, sometimes I had to figure out why it didn't work right, and some of it was me not reading the manual properly. But hey, we found it. It did everything it's supposed to do. It's working about as good as I've ever seen it work. I'm confident in its calibration with what I have. I don't have a power meter. A friend of mine does. I didn't feel like ordering it, borrowing it from him, but I'm confident this thing will work when I turn it on. I'm going to button it back up and figure out what I'm going to do with it. I'm going to hang on to it. Never know. Anyway, it's been a long ride on this one here, and I guess when I've got a lot of editing to do on this stuff and try to cut some fluff out. Probably be about 3 or 4 parter maybe. I'm going to probably just edit the thing as one and then just split it up there. I think that's the simplest thing to do. So anyway, thanks for riding along. It was a kind of a kind of dark brown type thing, you know. Sometimes I just get carried away on what I do, but I won't let it beat me. I sat down, studied it, figured it out, reread it, slowed down long enough to reread it properly. So I'm happy. It's working fine. Let's see, what else did we do? We also cleaned the vernier control, the output vernier control, because it was very, very dirty. Matter of fact, it would cause it to go, what do they call that, unleveled, and I would have to turn it off, turn it back on, so it took care of that problem too. So everything looks good on it. Everything did like it's supposed to do, and I'm happy. And thank y'all for joining me, and we'll see you on the next one. Adios.